Good morning, good afternoon, and good evening to all of our attendees joining us today for this latest Data Science Central webinar. This is Sean Welch, your host. I'm the host and producer at Data Science Central. I'd like to start our event off today by thanking Gurobi for sponsoring today's event. Gurobi is a longtime supporter of the Data Science Central community, and we're honored to have them sponsoring our event today. Today's webinar is entitled, Learn How to Design and Deploy Optimization Applications, to be presented by Gurobi. Before we begin, I'd like to briefly review the format of today's webinar. Today's event will be 1 hour long. We have one presenter who I'll introduce in just a minute. There will be a 10 to 15 minute Q&A following the presentation. And this event is being recorded and will be available on datasciencecentral.com later this afternoon following today's live event. I'd also like to encourage our attendees to provide questions throughout the presentation. We'll be reviewing and presenting them on your behalf during the Q&A portion of today's event. Well, I'm very pleased to introduce today's speaker, Richard Oberdieck with Gurobi. Richard obtained his BSc and MSc degrees from ETH Zurich in Switzerland from 2009 to 2013, before pursuing a PhD in chemical engineering at Imperial College London, UK, which he completed in 2017. He has published one book, 21 papers, and 2 book chapters, has an H index of 11, and was awarded the FICO Decisions Award 2019 in Optimization, Machine Learning, and AI. He's now helping companies around the world unlock business value through mathematical optimization as a technical account manager for Gurobi Optimization, LLC. Thanks for being with us today, Richard. We're looking forward to your presentation. Interested in learning how to build and deploy modern optimization applications that deliver tremendous business value? In today's Data Science Central webinar, you will have the opportunity to see several live optimization application demos. These demos will showcase the power of mathematical optimization applications and demonstrate how you can deploy these applications on modern IT architectures like Amazon Web Services and Docker. We will cover well-known optimization problems, such as the facility location problem and workforce scheduling. We will give you an in-depth look at the user interface, the architecture, and the deployment of optimization applications. The webinar will illustrate the business value of optimization, demonstrate how to interact with an optimization application, and show how this application can be implemented within a modern IT architecture, and go over best practices in deploying your own optimization applications. Richard, with that, I'm going to turn it over to you. You can begin as soon as you're ready to go.
Thank you, Sean. So, welcome everybody to this webinar on designing and deploying optimization applications. And in the next, let's say 35 to 40 minutes, I'm going to walk you step by step through the process of coming from a business problem to an optimization model formulation, and then how to solve that on your local machine, then taking that local machine model and moving it into the cloud using our Instant Cloud product, and then finally turning this whole thing into a scalable application that you can use to create value. Okay, so let's start from the beginning. Let's start from the business problem. Imagine you are the manager of a supermarket and you have a number of employees and you have to plan when they should work and when should be their schedule. And when you're faced with this problem, there's a couple of objectives and a couple of restrictions that you're going to face. So the objectives you might have are that you want to minimize the amount of extra workers that you may need. So if you don't have enough people on payroll, then you might have to hire in short-term extra workers, but that can be expensive. It can be disruptive to business. So you want to minimize that impact. But at the same time, when you make your schedule, you also want to balance the number of shifts between the different employees. So you don't want that Anne, for example, gets 12 shifts, whereas Jack only gets 2. In order to create a fair schedule, all workers should be working a similar amount of shifts. But at the same time, you have certain restrictions that you cannot ignore. So the first and most important one is, of course, your shifts have to be staffed. So if you need 7 people on Monday, then you have to have 7 people present. So that's your key requirement. Another key requirement is, of course, you have to respect when your employees are available. So if Jack can only work Monday, Tuesday, and Wednesday, then you have to incorporate that into your schedule. So this is in a high level a business problem that you may face. And this is a very classical application for optimization. And so let's look at how we can take this business problem and transform it into an optimization model. To do so, we have to formalize our objectives and restrictions using equations, and which then Gurobi can understand and use to make an optimal decision for you. And in order to formulate equations, the key components, let's say the building blocks of equations, are the variables, right? So what do you use to describe the dynamics of your schedule? And in our case, we're going to have 3 types of variables. We're going to first look at what we call a binary variable. So it can be 0 or 1, which indicates whether a given worker works a given shift. So that's our variable x. Our next variable is going to indicate how many extra workers do we need for a given shift. And lastly, we're going to show how many shifts does a given worker W work. So with these 3 variables in place, we can now start formulating our restrictions and objectives to create a whole set of equations that describe our problem and that we can then use to make a schedule. So next up are the restrictions. Let's look at the first restriction that we have, which was that each shift needs to be staffed. And the way we're going to go about this is, if you look on your right, you see there is this sum over all workers that we have, W, and we add the extra workers that we have on a given shift. And that number has to be equal to the number of people that we need at a given shift. And that enforces that each shift is staffed as it needs to be. The second point is that we identify how many shifts a given worker W worked. So that, in form of equation, is simply summing for a given worker W over all the shifts S and storing that in the variable Z. And finally, we have the requirement that the worker needs to be available. And the way we handle this is actually that we only generate the variables X, W, S if a particular person W can work a given shift. So that way, already in the model formulation, we make sure that this restriction is not violated. And then lastly, now we can formulate our objectives. And those end up now to be pretty simple to convert into equations. The first one is to minimize the amount of extra workers. And that ends up being just the minimization of the sum over all our extra workers over all shifts. Equally, we want to balance the number of shifts between the workers. And the way we do this is we minimize the difference between the maximum number a given worker works and the minimum number. So if we think about the example I said before, where Anne was working 12 shifts and Jack 2, in this case, there would be max would be 12 and the minimum value maybe 2, so that's 10, and we would try to reduce this number as much as possible to create a fair schedule where all workers get similar amounts of work. Great. So now that we have formulated these equations, we are in a position to tell Gurobi what to do and to solve this problem for us. So let's go ahead and convert these equations into code. And as you'll see right now, this is we're going to use Python in this case. This is going to be very straightforward because the way that modeling expressions are implemented and shown in Python is very close to the way that it is written in equations. So first up, we have the variables here. And you can see on the left the formulations that we had obtained in the previous slides. And now on the right, you can see how those are implemented in Gurobi. You can see we first create a model object, and we define X, Y, and Z using one line that defines these variables. Next, we have the restrictions. So in the restrictions, we now formalize what we said before in code. And you can see that we have the first and the second constraint that says how many workers we need for a given shift and how many shifts a particular worker worked. And you can see how we can use expressions like a summation over all the variables here very natively to Gurobi. And lastly, we have the objectives. And in this case, actually, we have two objectives. And so this is interesting because now we can actually add more than one objective to Gurobi, and it will prioritize them and use them to guide the optimization as you have specified. So in our case, the first objective is the additional worker objective that we want to minimize that. And then our second objective, this is actually slightly more complicated. We have to define an extra variable that represents this minimum and maximum value. And then finally, we can write that also in an objective, as you can see in the second to last line. And finally, all we need to do is solve this model. And then we will get the optimal schedule for the particular set of input parameters that we have selected. Okay, so we are now at a position where we have a model running on our machine locally, maybe in a Jupyter notebook or in another form of IDE. And now we're going to look at what can I do to move this to the cloud. Say you're not running a schedule for 5 people only, maybe you're running one for 500 or 5,000 people, and that you don't want to run it on your local machine. Or, as it is the case in this presentation, what I'm going to show to you, you want to actually move away from your local machine and you want to make this available to other people outside of yourself. So you want to move this into the cloud. And how can you do this? And so this is what we're going to show you now is we have our model here that we've seen before. This is just a Jupyter notebook. And now when I run this now in here, this runs on my local machine, as you can see, and it solves and produces some output on the screen. But now what I can do with Gurobi is I can go ahead and say, right, I'm going to go to our Instant Cloud Manager, and I'm going to create a pool of machines, configure this pool of machines that run somewhere in the cloud. In this case, it is an AWS instance running in Virginia. And then I have this cloud, a pool of machines configured, and I can download the license file that is associated with that pool. So I can look at it. I can, if I see it, the only thing it contains is an access ID and a key that tells Gurobi where to look for those machines. And when I take this now, this license file, and use it in my Gurobi installation, then we will see that when I run this again, instead of running this code that we just saw on my computer, what happens is that the solution of this problem gets sent to the cloud. So now we can see it says set parameter, set the secret key, and so on. It shows how it's connecting to the cloud, firing up those machines. And you can see this now in the Cloud Manager as well on the left here, the turning symbol. So you're starting up machines now to solve this problem for you. Now, what's important here, this latency that you see, this waiting period, this only happens because the machines have to come up online. Once they're online, this is extremely quick. But I wanted to show you this to you that you have, with your command, you are firing up these machines on the cloud. And once they're provisioned for you, once they're ready to go, now we can establish a connection, send our data encrypted, solve it, and get the result back just as we would on our normal machine. And so what is really cool here, you can see that the pool is online. If we want to run this again, we can run it again, no problem. And we can use Gurobi away from our local resource in a scalable cloud environment. So what's the key feature here? What's the main purpose of showing you this? You don't need to change anything in your code when you want to move Gurobi from your local machine to the cloud when you use Instant Cloud. It also shows that you can scale your machine pool as you want. In the video I just showed, you could see that I had the option to configure multiple machines. So if our standard machine, which is an 8-core machine, is maybe not powerful enough for your setup, or you need multiple machines, then you can configure this on demand as you want and get those resources provisioned for you just as you need them to solve your problem. The next thing is you can also configure different pools to be used for different projects. So let's say you are considering making one pool for each supermarket. Then each supermarket is completely independent and will have an independent instance. They will all be managed by one license, but they will have independent pools. And what is crucial here is all of this comes inbuilt with Gurobi. You will need access to the Instant Cloud. Once you have access to the Instant Cloud, you have access to this. And all of this is, of course, encrypted, so that you don't have to be afraid that this gets transmitted in clear text. So this is really the power of Instant Cloud in a nutshell, and how easy it is to move from your local machine to the cloud. But now what we've done, we've only moved the solution process for now. So let's go take this one step further, and let's actually build an entire web application around this this model that we have just created. So let's look how that would look. So we can use microservice and containerization, and we can create a scalable web application like the one you just see now, where you now are in a web environment. You're in a demonstration environment on our website, and I will show you this later on in live as a live demo, where you can go through. You have your workers, you have your shifts, and now you can press optimize, which does the exact same thing as we did before, where it connects to the cloud. And you can look at the worker assignment plan, who works when, how, and you can look at your KPIs on how many additional workers do I have. And all of this is just an extension of what we started by moving to the cloud with the Gurobi Instant Cloud. And this is an example of how a web application can look like from your perspective as a developer when you approach it. Okay, so now let's look behind the curtain. This web application combines several different languages and frameworks. So let's look how we built this and how we thought is a good way to go about making such an app. So in our case, what we did is we split all of this up into small components, into small microservices that combined build this web application, present this web application to you. So on the left here, we have our user interface, and we've written this in JavaScript. We've used React as a framework and material design for the design components. And this is a scalable interface. This is also just JavaScript. And this connects using WebSockets to our web app server. And that's written in Node.js, again, general programming language that general JavaScript framework, excuse me. That is kind of like the brains behind the operation. So it's a stateless component that processes the requests from the web interface and feeds them to the backend, and equally takes the results from the backend. So for instance, if the optimization result comes back from the backend, it tells the web UI, hey, there is a new optimization result here, and you can now show this to the user. So this really is the center of the operation. Next, on the right hand side, we have the message queue. So the message queue basically just queues up all the different requests. You have to think, if you have many applications open at the same time, all the requests come in, you want to make sure that they are coming in a certain order, so that the optimization worker, which is written in Python, and this is pretty much under the hood, very similar to the code I've shown you before, can process and solve these optimization problems. And those are then stored in the scenario database together with the input. So the input and the output are matched up so that we have a record of what's going on, and you can actually show this then to the user. And then the final piece of this puzzle really is the Gurobi Instant Cloud, where you can see how the optimization worker, just like we saw in the demo before, connects to the cloud instance, fires up those pools or uses the pools that are already online, and then just sends the instance that we want to solve, gets the solution, and then sends it back. Sends the solution back. Okay, so this is really in a nutshell how we built this this application that I just showed you, and what are the key features here that is really, I think, important to understand and take away. All of the front-end components that you saw are open source. On all of these you can swap out as you want. So if you don't want to use React, if you want to use Django or Angular or something else, go ahead. It's not important. You can use whatever you want. This is just a web application like so many others in development today. And the next component of this is, of course, that it is scalable. When you containerize and modularize like we did in our demo, suddenly you have many more requests. Of course you can scale this up. Of course you can build this, fire up more web app servers and so on to handle all the requests. And this goes hand in hand with the way that we deployed this. We deployed all of this in a containerized environment. We use Docker and Docker Compose, and then we build up our app into these different containers, and then we deployed it together on AWS. And so this really is a good way to make sure that all of your components are that it's really easy to do continuous integration and to work with those components from a development perspective and from serving it to the customer in a scalable way. For our CI pipeline, continuous integration pipeline, we're using Jenkins, so another open source product that allows us to really handle all of this in a seamless way. And lastly, the last piece of the puzzle here really is this optimization as a service component that is the Gurobi Instant Cloud, that allows you to not worry, how am I going to solve this? Is my machine going to be big enough? Am I going to have enough computing power? Am I going to run out of memory? With the Gurobi Instant Cloud, what you can do is you can just leave the solution of the optimization problem to us. So it becomes a service that you call into and just say, hey, please let me solve an optimization problem. So this is, now I've taken you from the start of the business problem of how we're going to look at a schedule from a high-level business perspective of objectives and restrictions that we have to obey by, to a mathematical model, from the mathematical model to an implementation on your machine, from your machine, then to the cloud, and finally to a full-blown application. And what I want to show you next is the same type of structure, but I want to do a live demonstration for another type of problem, which is called the facility location problem. So let me share my screen now and show you how this looks like. So here I have opened a tab where we can see the Gurobi webpage, and this is just in Gurobi.com's resource facility location problem. In order to run this, you need to create an account on our website, but that's totally free and just takes you a few clicks. And then what we have here is a problem where, imagine again the supermarket scenario, but now imagine You have quite a few supermarkets all around the country or the region. And now you want to build warehouses to serve those supermarkets. So this is what this demo is about, and you want to find the answer to the question, where should I put my facilities? So these are our candidate locations, and we can add more. We can say, for instance, let me add one here, or here, or here, or here, to say, given these locations and given costs on building these locations, how many and where should I build so that all these light gray dots, which are my supermarkets, are served optimally? And then I can just press optimize, and you can see it selects a few components and then connects them to the supermarkets it should be delivering to. And if we look at this, this is the exact same setup as we had with the previous application, with the workforce scheduling application. So we have, again, the front end, which allows us to interact. We have, again, this optimize button, which when pressed goes through the app server, puts a request in the message queue, tells the optimization worker, this is the input data I want you to solve, and then finally sending this to the instant cloud. And you can look at the log files, for example, of those requests, and you can see all the data that we are transmitting, all the edges, and all of this that goes to the Gurobi instant cloud, and then finally the result that we get back. And you can even do more with this. So now you can, for instance, also change the costs, but you can also add another scenario. You can say, okay, great, I've done one scenario, now I want to do another scenario. And you can go back. And again, all of this is just plain JavaScript, or React in this case, that you can go ahead and just on Stack Overflow, whatever, find your ways to do this, and then build the web application you want, the exact right way you want it, so that it creates value the way you need it to be. And so now we have a new scenario here. And so now we can go, okay, let's add some new facilities here, maybe some more around here, maybe one here, and change the costs and optimize again. And we can see we get a new solution, and we can even swap between these two. So now we have the solution here. Want to go back, want to optimize again, and now we have this set up again. So all of this is, again, the power of web development, of scalable web development, paired with the Gurobi Instant Cloud, shown to you in this optimization application demo that you can have access to from our website. When you look at this, you can also click on this help button, and then you can see what's actually behind it. So again, similar to the example I showed you before, we have a problem description, and then we have a mathematical model. In this case, it's what is called an incapacitated facility location problem. And there are some equations that, exactly like in the example we saw before, in the scheduling example, describe what is happening in a mathematical way. And then finally, we have the implementation that is shown in this Jupyter notebook, and this is our GitHub repository if you want to have a look at that, where all these examples are shown. And then you can scroll through these and find what we actually did. And this is the code. And this way, you can see how we solved the problem. You can also look at the architecture, which, again, is the same architecture we had before, with all the components and how we think about scalability, how we use Docker in this component, in this context, and what we used for the deployment. And finally, we even made a REST API for this, where you can call this up if you want to. Okay, so now that I've shown you two demos, I really hope I can convince you that what we're helping to facilitate with Gurobi and with Gurobi Instant Cloud is to create modular, scalable web applications that use optimization. Because the truth is that at the end of the day, oftentimes you will have memory and CPU requirements from optimization that are pretty heavy. And you may want to scale differently for different customers, for different solutions. So all of this problem gets solved when you use the Instant Cloud. And these two demos that I've just shown you are great examples of what you can actually achieve with this when you put it into your application. So great, these are awesome examples. What's the next step? So if you want to get started with mathematical optimization, then you can just go to our website and select I am a data scientist. And then we have plenty of resources for everybody who's getting started to even advanced users and experts. It can take you from how to formulate a model, how are different things described in the best way mathematically, and to our resource pages, how can you write a certain constraint in Gurobi, all the way to our community forum where you can ask questions to a general public, as well as our support team that is also available. In particular, the demos that I just showed you, there's more of them. There's demos about the coverage of cell towers, so if you want to maximize how many people have access to cell phone coverage. You have a cutting stock problem, which is one of the famous problems in optimization, where you want to minimize the amount of material that gets cut. You have wind farm cable layouting problem, where you want to minimize the cost of putting cables between offshore wind turbines and bringing that electricity to shore. Then you have a resource matching optimization, traveling salesman problem, both of which are very common and well-known problems. The traveling salesman problem, for example, involves how to, as the name suggests, travel around cities in an optimal way. And all of these you can find on the website at Gurobi.com. Finally, I want to also mention the modeling examples, because not only for those that I just mentioned, we have actual web applications that you can go through, but we have implemented several more as Jupyter notebooks that you can find again on our website. And there you will find even things that some data scientists might be more familiar with, which are things like L0 regression, that really show how even for data science problems, optimization can be applied. And finally, if you want us to get started with Gurobi, and if you want to get started with Gurobi Instant Cloud, then just go to our website, gurobi.com/eval, or just write us an email at info@gurobi.com, and then we will help you find the right way on how to incorporate a Gurobi Optimizer into your product, how to use the Instant Cloud if you want to do so, and we'll take you on a way where you can actually realize business value, optimize your business value using Gurobi. And with that, I'd like to close. Would like to thank you for your attention. And Sean, over to you. I'll be happy to take any questions.
Richard, thanks for that excellent presentation. And we'll get started with today's Q&A session. And I want to thank the audience for their participation. We have a great many questions that have come in during the presentation, and we'll do our best to get through all of them in the time remaining. And during this Q&A session, I'll leave up this screen with contact information for Richard if you'd like to contact him for a copy of the slide deck following today's webinar. All right, let's get started. So Richard, the first question is, what does priority mean in the objectives in the code that you showed?
Oh, that's a good question. So let me go to that slide right here. So the question is referring to these two lines right here. So one thing that is enabled in Gurobi, that Gurobi allows the user to do, is to formulate what we call multi-objective optimization problems. So often in the literature, you will see optimization problems as saying this is a single objective that you can pursue, like minimizing cost or maximizing revenue. But there is a whole branch of literature that is devoted to saying, what if we have multiple objectives? How can we approach that? And in Gurobi, we have implemented this. So if you look here, you can see this command is set objective n, which tells Gurobi there's more than one objective. And when there's more than one objective, you can tell Gurobi you want to prioritize them differently. So in this case, we say we really want to make the minimization of additional workers our number one priority. But then, if there is a solution that doesn't change the number of additional workers that we need, but we can make it more fair, so this is a lower priority, then let's do this. So this puts square first the minimization of the additional workers with a higher priority, but then also tells the optimizer, if possible, please make it more fair. And so this power of Gurobi really is it's even more flexible. You can say I will allow a certain amount of reduction in my objective. So say, for instance, I will allow one additional worker if it gets me a fairer schedule. So this is really a way that you can be very, very granular in the way that you drive your optimization and what you want to get out of it.
Thank you for clarifying, Richard. The next question is, does Gurobi offer evaluation licenses?
Oh yeah, absolutely. So as I mentioned in the last slide, you can get a 30-day evaluation license. I would suggest to just email us, and then we will help you, because at the end of the day, the aim is really for you, when you get an evaluation license, to have the right setting where you can make use of Gurobi in the best way. So if you run it on your laptop and then say, you know what, this wasn't really fast enough, then maybe we could have helped you to find a way where you can really harness the power of optimization. So we strongly encourage you to take an evaluation license and to seek the dialogue with us to find a way where we can understand your problem and help you incorporate optimization into that problem, so that basically things become better for you and you can add business value using optimization.
Wonderful. Why do you stress the open source components in your demo? What is the advantage over a complete optimization studio?
Oh, that's also an interesting question. So when I stress open source components, there's really two angles to this. So the first angle is that open source components typically, especially the bigger ones, have very large communities. So if you go on, let's say, Stack Overflow, you can find for React and JavaScript thousands of pages on all sorts of questions. And that's just the nature of open source software, that in general programming software that is really attracts a large audience. There's so much being developed right now, and at least for myself, when I develop an application, I often run into situations where I don't quite know how to go about this, and then a quick Google search will get me to those answers. If one uses a proprietary setup, then it can be very difficult to get answers, or it just takes much longer. So you have to maybe send an email or make a phone call, and it just takes longer and longer until you have developed what you want. Equally, you also can't get inspired by the community, because the community will tell you, no, wait, you know what, we have found a better way to do this, a more elegant way to do this. The other component is that you can swap things out very easily. So this goes hand in hand with the containerization. If maybe a technology you choose today in 2 years is outdated. So let's say you build your application, everybody's happy, and you built it in a JavaScript framework that, let's say you build it in Angular. And then in 2 years, you figure out, you know what, I don't really want to maintain my Angular code anymore because the one guy I had who knew Angular left. But then I have this new guy who says you can do it in React, for example, or in Django. And you can just swap out that one component because ultimately they're just they're modular components. And so that's really, I mean, why we use microservices in the first place is to make it such that we have a scalable and modular application. And so again, when you look at complete software packages that offer everything, front end, back end solution, and so on, then you can't just do this. So you want to swap something out, it's going to become more and more difficult. Sometimes it is possible. It's not, I'm not saying that it is impossible. I'm just saying let's say the hoops one has to jump through to get to the solution are much more painful. And so that's why we actually, by design of our applications, really aim to use modularization and general components, well-known components as much as possible. Even for our modeling, we use Python, which is, the most used, second most used language after JavaScript in the world. So so really that's where this commitment to using open source components where possible really comes from.
Thanks, Richard. Next question is, could I create the same setup in my own cloud?
Yeah, absolutely. So I mean, all of this, you could even run this on your own computer if you wanted to. I wouldn't recommend it, but I mean, you could. At the end of the day, all of these components are general web applications and general web components. So you want to run this on your local AWS cluster, go ahead. You want to have it on your own custom built cloud, not on AWS or Azure, go ahead. So that's for all the web components, for the front end components. As for Instant Cloud, we have Gurobi Optimizer can, as I showed you, you can have it on your local computer, you can have it in Instant Cloud. You can also have other variations like a compute server, where you can have a dedicated machine in your network where you say, this is my one, as the name suggests, compute server. I'm just going to send my jobs to this and get the solution and get it back. In fact, the Instant Cloud is in reality nothing else than a compute server that we host on the internet and provide an endpoint for. That's it. So you can definitely recreate this, and we're more than happy to make optimization easy and flexible for you. The real aim on our side is to make it easy for you to harness what we know is the power of optimization, and so that you can bring value to your business and to your problems.
Fantastic. So Richard, since there are also open source optimization solvers, why should I go with Gurobi?
Well, I'm as much as anybody, I really like, as you heard, open source components. But with optimization, I mean, there's benchmarks, I'm not going to go out and quote them, but it is very well shown that a commercial product like Gurobi is orders of magnitude, many orders of magnitude faster than an open source component. So there are open source softwares out there, and they often do a good job to solve small problems or other types of things that you might encounter from time to time. But for an actual application, and for an actual something that I want to deploy in my organization, the power that a commercial solver like Gurobi gives you is so high that it outweighs any sort of open source benefits you may get from those open source softwares. Plus, there's also a risk factor. I mean, do you really want to rely for the open source library, or do you want to go with a commercial library that has a very proven track record of solving these problems over and over again and being, as our tagline says, the fastest solver that you can have. So I, in a nutshell, I think it's great we have open source solvers. I really do. But it's also true that they do not, on a performance level and on a feature level, compete with things.
Richard, you mentioned different machine sizes. What is the best machine size to solve optimization?
Well, that depends. I mean, it depends totally on your problem, and that's actually one of the things that that we look for during an evaluation is what machine is right for you. Because to give you an example, parallelization is great up to a certain point. So, for instance, 8 cores maybe is a standard machine size that we see in number of cores, but maybe for your problem, 16 cores would be much better and would give you a really big speed up that you need to solve your problem. But maybe 32 cores, from 16 to 32 cores, you don't really get much more, and that's really problem dependent, and that's not something we can give a general recommendation on before looking at your problem and what your needs are. Because yes, you might say I want the biggest machine that I can get, but also the biggest machine costs the most amount of money. So you might say, honestly, I don't need it solved in 30 seconds. I'd be okay with 2 minutes, and then suddenly you can look at different machine sizes. So one of the things that is really important here is that optimization is computationally really intensive, and you want to make sure that you always have a powerful machine, ideally the highest clock rate that you can have on the processor, and a lot of memory, because that's often a limitation. Memory is cheap, so that's not really often that's a problem you can easily solve. But beyond that, it is a question of coming together and understanding what you need, how you need it, and what size is then right for you. And then once we come to a conclusion, that we can test out different things and make sure that you're happy with the deployment that you get and the result that you get. And so ultimately it is something that we look at together to find the best solution.
Well, Richard, thank you. Great answers to some very good questions. And for those of you that asked questions that weren't answered today, we will be sending all unanswered questions to Richard and the Gurobi team so that they can follow up with you after today's webinar. I have just a few quick announcements. Please mark your calendars for May 26th, 2020 and our next DSC webinar, Collaborative Data Science Advisor. Also, today's taping will be available for on-demand viewing later today and can be found on the home page of Data Science Central in the Webinar tab located at the top of the page. And past webinars are available on demand at datasciencecentral.com. If you haven't had the opportunity to view them, I encourage you to take a look. They provide very useful insight into a wide variety of topics of interest to our data science community. Well, this brings today's webinar to a close. I'd like to thank our audience for their attendance and thoughtful questions, and a special thanks again to Gurobi for their sponsorship, as well as to our speaker today, Richard Oberdieck, for his insight into today's topic. My name is Sean Welch, and I'm very pleased to have been your host for today's event. I look forward to seeing you all again on May 26th, 2020. Have a great day.